So thanks very much for the introduction. And yeah, we want to be that dryad that actually lives in symbiosis with the trees, brings technology for the help of nature. That's the mission of the business. And we've been started as something that's called an impact for profit. An impact for profit basically means that the main mission of the company is to have a positive impact. And yes, we want to be profitable like most companies out there, but we always want to do both. So we engage only in projects that have a substantial positive impact on particular on climate change, which is our mission. And we use, of course, technology, in this case, LoRaWAN, and our technology to help in the fight against climate change. Now, how would you use LoRaWAN technology in the context of climate change? Well, wildfires are one of the worst problems that we're facing. And yes, it's not only California that's affected, it's a worldwide problem. In fact, most people don't know that wildfires are causing up to 20% of global CO2 emissions. That's between 6 and 8 billion tons of CO2 that can be traced back to the combustion of organic material in the context of fire. So it's about the same amount that the entire traffic puts into the air each year. So if we can stop wildfires, we can work on 20% of the biggest problem that humanity is currently facing, which is climate change and biodiversity loss. And the interesting part is that most wildfires are caused by humans. And depending on the region, it varies, but on average, it's about 80% of all wildfires can be traced back to human activity, which can be accidents, arson, technical faults, whatever. It's us causing the problem. Only 20% of wildfires are caused by the only natural source of wildfires, and that's lightning. So we are causing the problem. It means also we should be able to stop it, and that's our mission. And it's not just about climate change, which is really bad for us all. It's also about biodiversity loss. We're losing about 3 billion animals in wildfires each year. And biodiversity loss is completely underestimated. It's as threatening to humanity as it is the climate change. They go hand in hand. So when we prevent wildfires, we also, of course, have an impact on biodiversity. Now, fortunately, wildfires also have a huge problem on the financial side. And I would say maybe cynically or ironically, that's a good thing. Why? Because that enables us and others to actually create a profitable business to prevent wildfires, right? If there is economic damage, there must be someone willing to pay to prevent that economic damage. And that enables us to create business models that enables us to be profitable while preventing climate change with wildfires. So this is the basis. And of course, the problem is so big. There are many companies, and thankfully, many companies focusing on this and throwing technology and products at it. There are satellites. European Space Agency has satellites dedicated for wildfires. The NASA has dedicated wildfire satellites. Startups are even launching nano satellites to monitor wildfires specifically. And that's all good, except that, as always with technology, there is not a single silver bullet that addresses all use cases and is the best thing ever, right? So every technology, no matter which one you choose, has advantages and disadvantages in the application. And so do satellites, cameras, and sensors. Each of them have their advantages and disadvantages. Satellites are great because they can cover very large areas with the optical systems that they have on board. And they're good for detecting and more importantly, tracking the development of wildfires. But they're not really good at the early detection of it because they're quite far away from the action. They can't see through the tree canopy. If they're geostationary, they're 32,000 kilometers away from Earth. If they're low orbiting, they're 600 kilometers, but they're never there on time because they rotate around the Earth. So it's not the ideal system. Cameras are great, and there must be like 50 camera companies that detect wildfires when the smoke is rising above the tree canopy. And they're good too, because they can cover areas like 16 kilometers in radius and rotate. But it takes a lot of fire before they can detect it. So the fire has to be quite far developed before they can ring the alarm bells. And then if you talk to a firefighter, what's the most important thing in detecting fire? They tell you it's time. Time is of the essence. Every minute counts. If you tell them half an hour later, it may be too late to be able to extinguish the fire at all, because it has grown to a size that they can no longer be extinguished with simple methods. So time is what we are selling, because what we are trying with Dryad is what we call ultra early detection of fire. We want to be at the point in time when it's still so small, the fire, that it's easy to put out. And we want to detect a fire in the first 60 minutes and during what's called the smoldering phase. The smoldering phase is when somebody throws a cigarette, some idiot driving on a truck or forgetting to extinguish a campfire properly. The smoldering phase, you do not have an open fire, but you do have basically, smoldering. So you have something that's heated organic material at 400 to 600 degrees Celsius, 400 to 600 degrees Celsius. That's emitting smoke, it's emitting gases, and that's where we are working on. We want to detect it that early, so to give that extra time for the firefighters to react as soon as possible. So what we've developed is a complete system. We call it SilverNet, silver Latin for forest, and net for the network. So we're building a network in the forest, and obviously we're using LoRaWAN for that. The first thing we had to do is to build a sensor. So we've developed a sensor, which is solar powered gas sensor that will be placed directly into the forest. So it's going to be attached to the tree stem at about 3 meters height. It's using solar panels to power the device. We don't have any lithium-ion batteries because we didn't want to bring fire starters into a fire detection product. And instead, we're charging the super cups in here with a solar panel that has enough energy to work then through the night. It does work under the tree canopy, so in the shade. So there's enough energy still available from the ambient light to charge the super cups for the night. It's going to be attached at about 3 meters height to the tree stem, and it can stay there for 10 to 15 years. That's how we've designed it, of maintenance-free operation. Now, we do, because we're talking technical in LoRa here, we're quite proud about that. We obviously use LoRa, but we also do support firmware update over the air, fully implemented in the device. Because if this device that is out there for 10 to 15 years, we'll need to update it. So the sensors do support FOTA from the very beginning. We're also using machine learning in the sensors. So the gas sensor that we have built in here is a Bosch BME 688, and we're using machine learning in the device to detect the patterns that are typical for a wildfire. So it's basically we train the models in the lab and to show it, like, how does it smell when a fire is ongoing, so that we can prevent false positives as much as possible. But that also means we need to update that, right? Because the environmental changes might happen. We want to optimize this. So we use FOTA to update the code, the embedded software in the device, but also to update the machine learning model. That's absolutely essential for what we do. And we also didn't stop at the sensor side, because in the forest, it's really pretty much the worst environment for telecommunications, because water absorbs radio waves, and the trees, guess what? They're full of water. So, the typical LoRa range of 10, 20, 40 kilometers, you can forget about that in the forest. You might get 2 to 3 if you're lucky, because the trees are absorbing that. So what we've created is a mesh network of gateways. So we created equally, again, solar-powered gateways that are LoRaWAN gateways to the sensor, but they have a mesh protocol injected into LoRa between the gateways. So that enables us to create a network that goes further and further and further and further into the forest, because we'll have to cover really large areas, and we cannot put a traditional LoRaWAN gateway in the middle of nowhere, because there's no 4G coverage anyway. So we need to do that on our own. And then we have these border gateways, the guys on the right, and they are then connected over 4G LTE with 2G fallback. and we've built a swarm satellite modem built in as a fallback in case the 4G is not available. We'll connect directly to the satellite to send out the alerts. Of course, we also have a monitoring platform where we're collecting the data. We're also sending temperature, humidity, and air pressure, but most importantly, fire alerts. And we're collecting those. We're doing device management in our monitoring platform. This mesh thing we're quite proud of. We invested a lot of effort into it, and it wasn't really easy because the standard LoRaWAN protocol doesn't support mesh. So what we've done, instead of implementing mesh at the sensor level, which is what others are doing, we've implemented mesh at the gateway level. So the gateways we have in between themselves, we've done a proprietary mesh protocol between them. It's like a range extender repeater, you could say. And they basically forward the messages in a multi-hop mesh network until it eventually hits what we call a border gateway. And then the border gateway, that is then connected over 4G, LTE with a 2G fallback, or over satellite, or maybe over Ethernet if there is a local Ethernet connectivity available. And that relays it to the internet, eventually hitting our cloud platform. So that's the system architecture. And that enables us to go really into very large scale deployments in the depth of the forest, in the middle of nowhere, where there's nothing. There's no power. There is no 4G, no 2G, there is no nothing. We just take one of those gateways, you attach it to a tree, and it will serve 2-3 kilometers radius. And the next 2-3 kilometers, you put another gateway and another gateway and another gateway. So hop by hop by hop, we can reach deeper and deeper and deeper into the forest. All based on LoRa. So the gateways between themselves also talk LoRa. And they're transparent LoRa from a LoRaWAN perspective when talking to the sensors. And so the mesh gateways are transparent for the sensors, and the border gateways are transparent to the network server. So we speak LoRaWAN on both sides of the system, towards the network server and towards the sensors. In between, we obviously have done a proprietary mesh protocol. The advantage of that approach is we can also integrate third-party sensors. Right? We do temperature, humidity, air pressure, and fire, and that's great. But what about soil moisture, subflow, tree growth, whatnot? There's so many things you can gather in the forest, and not everything we will be able to do. So we're open, in principle, for adding third-party sensors to our network and then benefiting from the large-scale deployment that we have in the forest. Okay, I'm being asked a lot on the sensor side, well, how many sensors do you need per square meters or hectare or whatnot? And so we've been asked a lot. I've created a slide for it. And so here's an example of an area of 3,500 meters, or 3.5 kilometers by 1.5 kilometers. So it's about 525 hectares. And given the fact that the vast majority of fires are human-induced, it makes sense to put the sensors in a higher density in areas of human activity and space them out more widely where there is very little or no human activity, right? So because then the overall system cost will come down. So one of those sensors we're selling for about 48 euro, really low cost, even at German manufacturing cost. And but we still want to bring the overall system cost down as much as possible. So let's focus more sensors on areas where there's human activity. Like in this case, we have a street going through a forested area. That's why you want to put all of those sensors really dense, because that's where the truck drivers throw their cigarette. And in the remote areas, where it's most likely only lightning that can cause a fire, yeah, you can space them out more widely because the probability of a fire being started there is much lower. So on average, we end up here with about 0.2 sensors per hectare, or one sensor covering an area of 5 hectares, which is 1 hectare is 100 by 100 meters. Sorry, I don't know the acre conversion, but I'm sure you're going to be able to work it out. Yes, and that's basically the technical part of Dryad. We've been working on this product for 2 years. We are now 20 people. We're growing to about 30 by the end of the year. We have 10 installations running in parallel in Greece, in Spain, in Turkey, and in the United States. as well, because of course California is one of the most interesting parts commercially and strategically for us. We are doing initial deployments now. We're scaling the product as a next step. In October, we're going to manufacture 10,000 units of this with our contract manufacturer. And then for next year, we've given an order for 230,000 units because we're quite optimistic that we can sell a lot of those. So we're at the point where we're actually scaling this. It's still early stage for the business, but we think we've got something unique and something that works better than other solution. And of course, it's LoRa based. But going back to the topic of this talk, technology is great, business is even better, but we really, really want to have an impact. So there are many companies, like pretty much everybody saying they're green these days, but we really want to be green. But what does that mean? We have targets. We have targets like we have revenue targets and profitability in our business plan. We also project the environmental impact that we will have. Yeah, and we do that just as seriously as we calculate profit and revenue and all of that. So based on the projections of the number of sensors we want to deploy, by 2030, our projection is that we would deploy about 30 million sensors of this. That's of course ambitious, but like every business plan, that's our business plan. Now with those 30 million sensors, we can project that we would be able to save about 1.4 million hectares of forest from burning that otherwise would have burned. Now, and then you can see, right, how much CO2 would actually have been emitted if we hadn't been there, right? And that can be translated into about 600 million tons of CO2 that we would prevent from emitting, and about 85 million animals that would have perished in those fires. So that is the impact projection. Like everybody says, we want to have like 100 million revenue and X amount of profits. We do that too in our financial plan, obviously. But we also project how much impact we will have. We quantify this and we take this extremely serious, just like we take into account profitability. And economic damage we would be able to prevent would be about 11 billion of financial damage that would have occurred, because we're projecting that our system will be mostly deployed in areas of what's called the wildland-urban interface, the areas of intersection between human activity, like villages and roads and electric infrastructure and nature. And that's of course a high value that we are protecting, and therefore the economic damage, and that enables our business model. Yes, and this, I think, concludes my overview presentation. I'm a bit faster, actually, than the 20 minutes I had been given. So maybe we can have a bit more open conversation. If you have any questions, I'm happy to do.
Yeah. You're talking about connected, let's say, sensor, okay?
Yeah.
Which is the ratio between sensors and gateway, and basically, if in the actual mesh network that you design it, the question is the relationship between number of sensors and number of gateways, and as well in terms of amount of gateways, if all the mesh network gateways need to have embedded basically sworn, let's say, satellite connections. So which is the ratio that you use at the moment for this, let's say, to reach this coverage, basically? Yeah, so to go backwards, first, the last question first, maybe. So the internet connectivity and satellite connectivity is in the border gateway. That's the smaller device on the right. And typically you have only 1 or 2 per network, and then 20, 50, 100 mesh gateways. So the border gateway is what is connected to the internet over 4G, LTE with 2G fallback, and that also has the swarm connectivity as a fallback in case 4G or the other internet connectivity is not available. So you only have 1 of that. And then you have, we're talking about, we estimate a ratio of about 100 sensors per mesh gateway, and then a ratio of 20 to 1 between mesh gateways and border gateways. Now, theoretically, there is no such limit.
because LoRaWAN in its protocol does not register the sensors, right? You could have millions of sensors connected to one gateway as long as they are not exaggerating the maximum throughput of the network. So theoretically, in our case, you can also have millions of sensors, but practically, of course, we're limited to the maximum throughput of 50 kilobits in a LoRaWAN network, theoretical throughput, and practically maybe 10 kilobits. So currently one of our sensors sends the temperature, humidity, and air pressure every 2 hours. That's about 6 bytes. You can then work out how many you can have to reach the 10 kilobits. Of course, we can change the configuration of the sensors that maybe they don't transmit every 2 hours, every 4 hours, so you can get more sensors in. But our rule of thumb is we say 100 sensors per mesh gateway. We feel comfortable with this, and 20 mesh gateways per one border gateway. If you want to expand the range into even larger areas, well, take another border gateway, again with 20 mesh gateways, again each with 100 sensors. So you'll build multiple islands, so to say, and with all of those you can cover very large areas. Yeah.
This is Marco from Kickmaker, Paris. I have a question about, okay, I know it's not battery operated. Does the product have a lifetime? Do you have a projected lifetime? And how do you retrieve the sensor which basically died in the forest?
So we do not use batteries in neither the gateways nor in the sensors. We use supercapacitors for several reasons. One is lithium ion is prone to fire. If it gets punctured, it starts to start a fire. It also is poisonous, so it gets in the ground. That's really bad, and we don't want that. And also it has problems with temperature, operating at low temperature. It also has problems with the number of recharge cycles, and we want to operate 10 to 15 years. And so batteries was not an option. So we went for supercaps, and we've designed the system to really last for 10 to 15 years. This is all encapsulated in plastic. It's filled with resin, so there's no moisture can go anywhere. So we're confident that this can last for 10 to 15 years. So confident that we're giving lifetime warranty. So in case one fails, we'll give one for free. But the question is, it's of course not biodegradable. So at the end of the lifetime, will need to be recollected. Like this has to be installed at the beginning of the lifetime, and at the end of the 10 to 15 years, we'll need to collect it again and recycle it.
Okay, thank you.
Hi, Carsten. How are you?
Hi, I'm fine.
So, two questions really. You said the sensors push the temperature and humidity data every 2 hours, but I think you've told me before that the fire detection is interrupt driven, so it will it push
immediately?
Immediately.
Yeah.
Okay.
Yeah.
And the second one is
sorry, not correct. We check once per minute. The sensor wakes up once per minute, takes a deep breath. Does it stink? And if it stinks, it says, "Oh no, I'm going to do a gas scan and use machine learning." And then I'm saying, "Oh, this is really a fire," then I'm going to shoot immediately. Okay. So once per minute.
And my second question is on deployment. I mean, do you partner with? How do you get these thousands of sensors out into a forest? I mean, is that a team that you have? Do you partner with forestry services?
Yeah.
If you could explain that, that'd be great.
Yeah, we're a products company. So we develop the software, the embedded software, the electronics, and the network and the cloud platform, but we will not do the installation. This is something that is something that either the customers themselves will do, if it's a forestry company, which is one target is the forestry industry that wants to protect their stands, their forests, and they of course have forest workers, right? So they've got no problem sending a troop of people into the forest and climbing up 3 meters, nailing it on a tree, going on to the next. There is no configuration. You just take one, attach it, go on to the next. So it's bloody easy to install, but it does need to be installed manually. You can't just airdrop it, because then the solar panel wouldn't work, at least not with the current product. In other cases, municipalities is the second target. or of course, we will work with companies that are providing forest services that are also servicing the municipalities' forests, right? They are happy to take the job of doing the local installation. And the third target is utilities, like electricity companies that are causing fires with their infrastructure. And again, they have maintenance crews that go out and service their power lines, right? So they can also take this and then attach it to every pole. So we're not going to do this.
Just a quick question. The geolocation is on the gateway, not on the sensor then, right?
Now, currently, for cost reasons, we decided against a GPS chip. So the sensors do not have a GPS chip. We sell this for 48 euros end user price at German manufacturing cost. So adding a GPS chip would be like another 5 euro. For what? These things don't move. They are installed. And when they're installed, we need to record where they have been installed, which is what we're doing with the QR code on the back. And we have a mobile application for iOS and Android that the forest worker takes, and it guides the forest worker to the next location of installation, where to install it. And then they take a sensor out of the back, nail it to a tree, and take a picture of the QR code. And the app, which works in offline mode, records the geo coordinate of the smartphone, and then synchronizes that back to our database. So that's how we know. We don't do currently geolocation of the gateways. That's like with triangulation. That's interesting and technically possible, but also challenging. We've taken the brute force simple approach with taking a picture at the moment. It was easier. But GPS is interesting. So for example, we're quite interested in the LR1120 in the future because that has off-board GPS capabilities, and that would enable us to remove this additional step of taking a picture. But adding a real GPS chip and the BOM cost for that is not really viable. It's 5 euro for what? It's not, that doesn't make sense. Yeah.
Carsten, can I just ask, how easy has the sale been? I mean, is this your projections are look very good? I mean, is it? The public sector traditionally is quite slow moving in its decisions and stuff. Has it been very easy? I mean, clearly the advantages look great, but I wonder if you've got proof points and you've got from your installation so far, there has been some record of the kind of savings you can deliver, this kind of stuff. How does that work?
I mean, it's never easy to sell a product that doesn't exist before, right? So this is a new product. So you need to convince people that this actually works because we can't just say, hey, we're better than product B. We have to explain the concept, and then you have to prove that it actually works. Everybody can do a nice PowerPoint pitch and be very convincing, but you need to prove it. And that's what we're doing now. So the go-to-market is we're doing 10 small-scale installations. They're live now with customers, and they can see themselves. We send them a kit, 16 sensors, 1 mesh, 1 border, go, install it. They install it, they light a controlled fire, the thing goes bing on their phone. That's what it does. So it works, okay? So once we've pushed through that, then we'll go to the next phase, which is in October, where we're going to manufacture 10,000 units. We're going to do pilots with a few hundred sensors with the same customers. And then they can see, oh, it also scales. It's not just small and works, it also goes large. And then next year, we want to go all in and say, how many thousands do you want? So that's the state. But do we have a lot of proof? No, we don't, because we just finished development in February, and now we're doing the first deployment. So this is still an early stage, but we're obviously quite confident, and the feedback of the first POCs have been very positive. And it works, just works. The best experience was recently, I was there in Spain, the municipalities, these guys, they employ in Guadalajara, it's the north of Madrid. They employ 400 firefighters full-time, doing nothing else but fighting forest fires. 400 people full-time. And with these, we did a test installation, and they did a prescribed burning. So we get the chance to put 10, 20 sensors into an area, which they then intentionally burnt. And that was quite exciting because our sensors were in the middle of a real forest fires rather than a small test fire, so like a proper fire. And of course, it detected after actually 5 minutes. We had the first email saying, "Hey, there was a fire," and then eventually everybody went off, all of them, and one of them got really burned, and the poor guy kept on sending the alerts, and it really was melting in the end, but it kept on going, so it's still alive now. So we're quite optimistic. But is it an easy sell? Nothing is ever an easy sell. Of course, you need to convince people that it works. You need to gain the trust. And yes, municipalities have a long sales cycle, 18 months, no question. We also sell to forestry, private forestry. They're a bit faster, right? It's your forest. Just you want to save or you don't want it. So it's easier decision cycles. And electricity companies, well, they're also a bit slow, but yeah. Thank you. Thank you.